Hey guys, since he's going to be late, does anyone want to start doing some review together?
Uh, hey Jennifer. I mean,
Hi.
if there's something in particular, I guess you wanted to look at or work on, I'd be down to review some stuff.
Um, well, I didn't get fetch information. I missed that part of the video, part of the class. But
What part of the class are you referring to?
when you guys were going over fetch on Wednesday,
Yeah. I mean, I'm not familiar with it enough to like really like pick an example like the way him and Max do to go over it. But like, if there's, have you gone over it? Was there any like concept or part of it in particular that you didn't get, or?
no, I have to watch the video. I'll have to watch the class so I can get it and figure it out.
In the meantime, I would suggest, and I mean, this kind of applies to a lot of the concepts that we see in class. Like, I would just Google like fetch and like JavaScript, just read little documents and stuff and just see, just to get familiar with your idea. So, like, before you even get to the class or before you see the video, you have an idea in mind of like what fetch is supposed to do.
Yep.
And yeah, I would just Google it. Like, there's probably a ton of resources just to give you a quick read. That would just be my suggestion.
Yeah, that's really perfect. I think that is the best way to do it.
So I didn't know that we had a quiz, but I'm not seeing the questions. Did anyone have an issue?
There's no quiz. There's not supposed to be a quiz, but it was put in there. So it says that it's being graded and we get a 0, but there's no supposed to be a quiz there.
Oh, okay, thank you. Because I'm like, I don't think he mentioned a quiz.
Mm-mm. Alexa, play music.
Here's a mix for you on Amazon Music.
Alexa, register for unlimited music.
An earlier request to cancel Amazon Music Unlimited is set to take effect with the next billing cycle. To make other changes, visit your Amazon Music settings on the web.
Jennifer, you're not muted. I didn't know if you wanted the music to play.
No, I don't, sorry.
Hi, folks. Apologize, I'm a little late here. How's everybody's weekend?
It was good. It was good. How was yours?
It was moderate. Got a lot of stuff done. Cool. Okay. Christy, there we are. Okay, make co-host. Cool. And I think that's all I have to do, right? Yep. Okay, sweet. So we had a fun class on Wednesday where we ended our class talking about something called fetch that I think made a lot of people a little confused. And I sort of said, okay, we can think about it over the weekend. We had a nice open hack. I got to meet a lot of you all in person. That was great. Had a nice weekend. Now we're back to it. And we're back to talking about fetch again. So generally, I haven't prepared too much over what we did yesterday. My plan is to largely sort of start going through the same lesson again, sort of through it one more time. That being said, though, we didn't really get fully through the lesson last time. We sort of kind of left it at sort of like an example, and that was it. My goal for today is that everyone can make a fetch request on their own computer, like on their own. So it's like, we'll see how far we get there. But my hope is that because this is going to be somewhat of review, it'll be a chance for everyone to like, they can actually follow along and not be focused on like fully grasping material that they hadn't heard before. So we'll see how that goes. But yeah, I think that's about it. So let me get the presentation up here. I apologize, I'm not as prepared because I just got out of a work meeting that went a little long, and that's that happens occasionally. But here we go. Okay. One thing I did do, I added a slide sort of before we get into this, because one of the things I tend to do is usually the thing I've been doing in Careers in Code, this sort of module I teach is 2 weeks. So at the first day of the second week, what I like to do is show an example of what we're actually working towards. So we had a homework assignment this past week, but we're gonna have another homework assignment at the end of this week. And this is gonna be your homework assignment for the end of this upcoming week. And what this is, we're gonna be building this thing called the New York Times bestsellers list. It's sort of a project that has a bit of a reputation here at Careers in Code. What this is the website that makes requests to the New York Times API. And what it does is it comes back with a list of books. And the goal of this project is to render these books on the screen and sort of style them however you want, in whatever sort of way you'd like. If I reload this, you'll see like it, oh, well, it just is going to happen instantly. Well, that's not so fun. But what happens here is like the page when it first loads is like empty. And then some code runs and sort of these books show up on screen. And what I wanted to show you here, the reason why I bring this up kind of at this point in the module usually is because this sort of gives you a very clear example of something you can build with Fetch. Something where you're making a request to another service somewhere, API out there, and then you're getting back data from that API and you're doing something with it. In this case, you're showing it to the user in a way that sort of presents them information and gives them something that they can get value out of. Like, you can come to this and learn about some books you might want to read. Like, that's like a real thing. Like, this is an application that actually does something helpful, useful. It's not just some contrived example I thought of. So anyway, we're going to be going through this later this week, but I just sort of wanted to show this to you now so you could sort of take a peek at it, start to sort of understand all this information in context. Okay. So let's sort of let's go back through what we did at the end of last week. So we talked about the day before Postman and curl, which are two sort of tools to make requests, HTTP requests. Postman is a graphical tool. So you open it up on your computer and you sort of can like enter stuff into text boxes and click submit and it'll make a request and then you see the response and it's great. Curl is a command line tool. So curl, you enter the command curl into the terminal, you type a bunch of stuff after it, and you hit enter, and the request gets made, and it shows you the response it got back. Fetch is another tool like this, like these two categories, but it works in a third environment. It works in the browser. So fetch is a thing you run in JavaScript. It's a JavaScript function built into a web browser, just like document.createElement or document.getElement by ID. You know that one, I think. Or like console.log, or it's a thing built into a web browser. So you don't have to like add it in. It's not like a library you have to bring in. It's just there. And it's probably these days the most actively used one of these tools, these HTTP request tools in a web browser. A few others. This isn't all that important, but I put this here in case folks are curious. So these are some other tools that historically have been used quite a bit to make requests in browsers. But we're going to be talking about Fetch. And yeah, we're talking about Fetch because it's built into the web browser. I just said all this. Yeah, they all have the same concept. So if you're sort of going to be using one of these tools and you sort of later on are told, oh, we need to use a different one, like it's all kind of the same. Fetch is just, it's built into the web browser. It's going to be easy to sort of get started with. So that's why we're talking about it. But it's a global JavaScript function. So it's a JavaScript function. It's built into JavaScript. It accepts parameters describing a request and then makes that request asynchronously and then provides a response. Okay, that's a lot of terms. We talked a little bit about what all this meant before, and I'm going to sort of do that again here. So as I said, global JavaScript function sort of in the browser by default. You don't need to bring anything extra in. It accepts parameters. So it's a function that sort of takes arguments, takes parameters, and they sort of describe the request stuff you want to send along with it, the information you want to send in that request. So like a method, a path, a body, headers, the host name, the port, all that sort of important stuff. And then it asynchronously makes that request, which is something we briefly touched on last week, but let's touch on again. And once it makes that request, it gives you back something in JavaScript that has all the response information in it. So that object might have like a status key for the status code, or a key that's like a body to get like the body information in there, things like that. Now, asynchronous. I think that's next here. Oh, no, we got some examples. Yeah, let's go through this first. Let's talk about the syntax, then we'll talk about what the asynchronous thing means. And also, like, as I'm talking here, I'm repeating everything kind of from last week. Please interrupt me. If you don't understand something, mention it, just like call it out, because I'd much rather sort of pivot right now and talk about it than sort of have you go through the whole class and not know what I'm talking about and address it at the end or not address it at all. So fetch, it's a function. it takes two parameters. The first parameter is the URL you want to make a request to as a string. So you got it in quotes there. And it's a URL. So it's at the beginning with the protocol, http://. The next has the domain name or the host name or an IP address, sort of the thing you're making the request to. So example.com, 192.168.1.5, whatever sort of IP address or thing you want there, an optional port, and the path at the end. So those sections. By this point, I hope URLs are probably familiar to most of you. That's something you sort of are starting to understand. So unless I hear otherwise, I'm not going to spend too much time on it. The second parameter, though, this is where things start to get more interesting. This is the options. So these are options that you specify that sort of tell Fetch what to include in the request. So method, that part of the request. I'd also assume hopefully by now you kind of know what methods are, know what headers are and what the body is. These are sort of those bits of information. The headers sort of is an object, so it's like an inner object within the options object here. So you sort of have this curly brace and this curly brace, and that's sort of the object itself, that second parameter. Within it, you've got a bunch of keys and values. But the value of headers is another object. So you sort of have like one object with one inside of it. There's like two there. And inside the headers, you've got a bunch more key value pairs. So authorization, super secret, whatever sort of thing you want there. We're going to talk about headers more tomorrow. All the different types of headers and sort of what they do and all that. But yeah, and this is sort of what you would do if you wanted to make a post request to example.com with an empty path or the path of slash, with a header of authorization mapped to super secret, with a body of testing 1, 2, 3. This fetch would make that request. So at the end of the day, like, you can think of this like a template. You're plugging in all the stuff from your request into this sort of function, and it's able to make that request, and what it's going to return back to you is an object that represents the response. Okay. Cool. And yeah, we talked about this last week, but this is sort of how that maps one-to-one from the fetch to the actual request that's being made via HTTP. So on the left here, we got our path that sort of maps over. We got our method, our headers, and our body. Now, I should also mention that everything in the options object, so all the method, the headers, and body, these are all optional. You don't have to specify them. If you don't specify them and you just leave the options object empty, or even omit the options object altogether and just give fetch one parameter, then it's going to default to these values. So the method will be get, the headers will be an empty object or no headers, and the body will be an empty body. Okay, this is where I suspect for most of you stuff started to get a little more complicated. So just before I move forward, in general, can you just give me like a thumbs up or a thumbs down? As far as like the actual syntax of like the fetch, like the function you're running, does that part make sense? I realize you haven't actually written this out like yourself yet, and that might help a little bit here too. But I just want to get like a general check as to what's the place that folks are struggling with. I suspect it's probably promises, but I just want to validate that. Okay. Cool. I'm seeing a decent number of thumbs up, so I'm going to sort of assume that I'm probably right in that assertion. But if you want me to talk about this more, bring it up. I can do that. Okay. So the return value from fetch is different than a lot of other functions you've worked with. So I'm going to open up VS Code again, and it's probably still going to have open what I did last time. It does. Okay. Very nice. Oh, it gave me a new version. Very fancy. Okay. And I don't care about that. Cool. So I'm going to get rid of a lot of this stuff here. Okay. Cool. And I'm going to get rid of this. This is from before, and I think that probably was more confusing than helpful in hindsight. Okay. So what I have here, and you are welcome to follow along on your end, is I made a file called index.html, and I just put in sort of my boilerplate HTML in here. So this should be, by this point, very familiar to all of you. I have a script tag in here, and the script tag is I'm going to write all my JavaScript for today. I could also have like a script src in a separate file, but it doesn't really matter here. Max said you were familiar with both, so and this is easier for me, so I'm going with it. Okay, so if I write a function, I'm going to write a function called add. It's going to take two parameters, and it's going to add those two parameters together. I'm going to run add, something like this. I would suspect probably the most of you sort of have a guess as to what's going to happen here, what it's going to log out. If you say 3, you're right. 3, hey, there we go. Cool. This is what's called a synchronous function. Why is it called a synchronous function? Because what's going on in this function is happening immediately. It's sort of running, and it's getting the result immediately, and it's happening all within JavaScript. So if I'm the JavaScript interpreter, I'm running through this program. What I'm going to do is I'm going to come across function and say, oh, okay, this thing, I'm defining a function. It's going to say, okay, return, okay, cool. So I'm going to make this new function. I'm going to sort of register that for later so I can call it if I want. And I'm going to come down here to line 11 and say add 1, 2, and it's going to say, oh, this is the thing. This is the function. I got to call this function. And it's going to say, okay, add. There's like an add. Yep. Okay. There's an add function up here. So it's going to call add. It's going to give it 1 and 2. And it's going to go return 1 plus 2. It's going to be 3. It's going to return that. This is going to evaluate to be 3. And then console.log is going to log out 3. So I'd suspect that probably makes sense to most of you. But the important takeaway here is this is happening immediately. When I run like same sort of thing, but like something like this, like this result, like after I get past line 11, this result has a value in it. And it's got like the value of 3. Not everything you do in JavaScript follows this pattern, though. So we're going to talk about something different, a function that doesn't follow this pattern. And this is not related to fetch, but I think in order to understand promises, seeing like a non-fetch example might be helpful. We'll see. Maybe I'm totally wrong, but let's give it a try at least. Have any of you come across a function yet called set timeout? Okay, I'm seeing some head shaking, so guessing not. Cool. In JavaScript, have you ever wanted to do something like run like a function and then like wait a couple seconds and run another function? Like, or like log something out, wait a couple seconds, log something else out. That seems like that'd be really helpful, right? Like some sort of way to like wait, like sort of like pause. And this is like a really important thing in a lot of programming languages. This idea of like being able to let the computer just sort of like pause for a second. A great example where you might need this is, let's say you're doing something where you like, you've got a value and you want to check, like you want to like ask the, like check to see if a value is correct. And you want to do something like you want to check it like every second. What you could do is you could have a loop. And in that loop, you could sort of run that code over in the loop and like do the thing, wait some time, loop, do the thing, wait some time, loop. And what you effectively get in a situation like that is something where if like that thing was like logging out some text, you'd see like text, wait a second, text, wait a second, text. You wouldn't just see like text, like you see like there'd be a gap in between each one. And this sort of pattern of having to wait in software for certain things to happen is a pretty helpful one. But I don't think you've done it in JavaScript. And there's a reason why you haven't done it in JavaScript, and because it's kind of hard to do in JavaScript. Before I talk about that, though, let me talk about how this normally works in regular programming languages. And then we'll talk about why JavaScript's different, because JavaScript's really different. So we're going to go regular programming language. So let's say I want to log out like hello, and then I want to wait a second and log out world. Something roughly like that, assuming that what's on line 16 actually waited a second. So in most other programming languages, you'll have some function called something like wait or sleep, usually what they call it. I'm going to use sleep. And it usually takes a single parameter, and it's like the number of seconds or milliseconds to sleep. I'm going to just say milliseconds. So 1,000 milliseconds is a second. So in a non-JavaScript programming language, like a regular programming language, this would, line 15 would run, it would sort of get to this line and sort of would like just pause there, like wait there, do nothing. Just sort of like what's actually going on behind the scenes effectively is you've got a loop that's running in the background over and over, just like that's sort of like looking at the system clock and is like, okay, this clock is sort of has this thing gotten to the point yet where I'm done sleeping. And it's like, nope, okay, it hasn't. Okay, go down again. Okay, is the clock updated now? It just sort of like keeps going around waiting, and sort of it's at line 16, sort of the program's just sort of like stalled there until a second goes by, and then it's done, and it's okay, I'm done. It breaks out and sort of now goes to line 17 and it logs out world. And that's normally how this works in a lot of programming languages. Now, this would not work in JavaScript. And you might be wondering why. I mean, it seems like it could work. Like what I just explained, it could be done in JavaScript. And you're right, it could be done. But there's a really important thing in JavaScript. And that's that JavaScript is what's called single-threaded. And there's an asterisk on this, which if someone's watching this later on, they'll actually be like, actually, no, there are ways you can be multi-threaded. But no, it's single-threaded for now, for this conversation. So I'm just putting that out there. It's single-threaded. What that means is JavaScript has one sort of like thing that can run commands at a time. So if you think about like it's JavaScript's focused on one line at a time, running code on one line by line. That's not how all programming languages work. Many programming languages will actually have multiple pointers that can sort of all look at different things and all sort of run different code at different times. And why that's a limiting factor for JavaScript is it means if your one pointer's hung up doing something, like for example, stuck in a sleep, then you can't do anything else. And if you think about a web page, there's a lot of stuff going on a web page. Like you're scrolling that web page is always having to re-render. You're doing things like clicking on links and navigating to other stuff. You're like interacting with things and having like animations go on. You're having like little like pop-ups show up. All that sort of stuff, like to some degree or another, is controlled by the browser. And if the browser is single-threaded and it's locked up in your sleep, it can't do any of that. So I'm not going to do this demo right now because I might actually cause some problems with my computer because I've got a lot of stuff running on it right now. But if you're feeling adventurous sometime, try going into the JavaScript console in your web page and running an infinite loop and just hit enter, like while true with like an empty set of curly braces after it or something. And what you're going to find is the whole web app, the whole web page locks up and you can't do anything on it. And it's the reason why I'm not doing it right now is it's actually kind of a hard thing to get out of. The easiest way is just reboot your computer, but like I'm not going to do that right now. It's also a thing in Chrome called the Task Manager. It allows you to sort of manually like kill stuff. But this is a problem. Like you can't, if you want to build like a web application that like feels good to use, you can't have this occur. So you might say, well, maybe JavaScript should be multi-threaded. And I would say, yes, maybe it should be. And there's some stuff that's happened in the future now that actually kind of makes it almost like that sometimes. But sort of like putting all that aside, let's just assume we have to take for granted like JavaScript is single-threaded. We can't do anything else. Like that's just sort of how it works. Well, then how do we do this thing? How do we like wait some amount of time? Well, so you might guess there's a way to do it. I'm not just like stringing you along here to be like, gotcha, you can't do it or something like that. That'd be really mean of me, wouldn't it? So the way you do it in JavaScript is a different type of There's a different approach. So JavaScript is what is called, it has what's called an event loop. So think about, in this sort of case, you have this loop that's sort of like when in the sleep, it's sort of going around in the background. Imagine with JavaScript, you sort of have like that like execution pointer thing, sort of like the line it's running, sort of like going from like here, 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 just sort of like stepping its way down and like, oh, you hit a function call, okay, it goes into the function, it runs that and it gets to the return and it goes back to where it was before, like that whole like execution pointer. Imagine that once that pointer gets to the end of your code, it sort of goes to like another spot. And that other spot is like sort of like a holding area. So let's just sort of, I'm going to get rid of this for now. I'm going to just put down here like holding area start, holding area end. Okay, that's the holding area. So I want to run this code. So it says goes up here, okay, calculates result, does all this stuff, and then it goes down to the holding area. And when it's in this area, what it does behind the scenes, it runs an infinite loop, sort of like spinning around. And what it's waiting for what's called an event to occur. And you can think of an event as like any sort of action that requires the browser to do a thing. So an example of an event could be you clicked on the web page. Another example of an event could be like you resized your browser window. Usually a user triggers an event, but a user doesn't always have to trigger an event. The easiest events to explain, though, are the ones that users trigger. Okay, so you're sort of in this holding area, in this loop, and you're waiting for an event to occur. Let's say that you click on the page. Let's imagine actually you've got a button, and that button's got like an on-click handler defined. I think you've talked about that. Sort of you can like call the function when they click on a button or something like that. Okay, so you've got that what's called an event handler defined. It defines a thing to occur, like a function to run when the event happens. And what will happen is when that event gets triggered, JavaScript will say, oh, this event happened. When you there were a bunch of functions that were registered to run when this event occurred. And it will run that function for you. And what it'll do is sort of in that loop, it'll say, oh, okay, got this event. And it'll find all the functions that are registered to happen when that event gets triggered. And then it will run each of those functions in series. So like if you have your on-click handler on a button and you've got a function in there that should run, it'll run that. And then once it's done getting to the bottom of all that stuff, it's sort of now back into a thing like this where it's sort of jumping through all the code one by one, going through it. And then it'll get to the end and it's like, oh, okay, I'm done. Back to the holding area again. It's sort of now like waiting for another event to happen. And why this is kind of cool, this whole concept, I should say, is called an event loop. This idea of like being able to have this like holding area where sort of the execution context lives when it's not doing anything else. Why this is cool is because you can start thinking, instead of thinking in like where the pointer is, you can start thinking in events. So what's cool is like you didn't have to do code around like handling click interactions manually. You just were like, if the click event occurs, run my code. And you just told JavaScript to do that, and it just sort of like figured out how to make that happen behind the scenes. It also will do a thing that's really smart where events have priorities. So let's say I'm in the middle of this code and an event occurs and it's like a really important event. Let's assume for a second that clicks are really important events. Like what it'll do is it will sort of actually interrupt this code and be like, okay, hold on, we're going to get back to this in a second. Let's sort of store all of where we are right now, keep track of like all the variables that are going on, all the sort of information about like what function we're in. Let's sort of put that on ice for a second, move over to this event, run this event, and then when we're done, come back over to where we are to sort of keep on going. So what it's able to do is a lot of that sort of behind the scenes prioritizing and stuff like that, that's sort of really important to this paradigm even working. Okay, so why am I explaining all this? What does this have to do with like sleeping? Well, you might be guessing, but what if we could do a thing like we could tell JavaScript that we have an event. We want to trigger an event to happen in a second. And when that event happens in a second, we want to sort of trigger all the event handlers associated with that event. And that event could be like time has incremented by a second. Like that could be like what the event is. And that's sort of the approach JavaScript tends to take, where instead of doing a thing where you're sort of waiting like in a loop in a sleep for sort of waiting for something to happen, instead you have sort of an event that gets, you sort of can say, say to the JavaScript interpreter, okay, in a second, I would like you to trigger this event. And the JavaScript interpreter will say, okay, got it. Let me sort of store that away. It'll be down in a sort of holding area waiting around, and it'll say like, oh, okay, it's time for this event to happen. And then at that point, it'll then call the event handlers associated with that event and run them all. So the way that you define one of these sort of events to happen in the future that's on a time basis is this function called setTimeout. This is a really kind of important JavaScript function, and I understand you haven't learned it yet because it's more of like a browser-based function and less of like a node function, and I believe you've done mostly node stuff so far, but it is a pretty important one. And the way it works is I can define a function. I'm going to call this after timeout. And in here, I'm going to do whatever I want to run after the timeout. So I'm going to say like just after timeout, something like that. So cool. That's pretty straightforward. Now I'm going to call this built-in JavaScript function, just like fetch is another sort of built-in thing called setTimeout. This is like a function that the browser has by default. Like if I go over here and do setTimeout, like this is just built into the browser. It's there. And I can give the setTimeout two things. It takes two parameters. The first parameter is a function. I'll give it after timeout. The second parameter is a number of seconds to wait until that event gets called, or that event occurs. I'm going to give it 1,000 milliseconds. And what setTimeout will do is it will register an event with JavaScript and say, in this many of milliseconds, run this function.
So what you're doing is you're running a function within that set of time. So 1,000 millisecond.
Yes.
That's what it, okay. So that's what it
Yep.
does. How would you know what kind, is it always going to be in milliseconds?
It's always going to be milliseconds.
Okay.
Yeah.
Perfect.
Do
Do you have to put zeros in the front of it, or is it going to know if you put
No.
1, it's going to know that it's 1 millisecond?
Yeah, like that's half a second. And like
Mhm.
that's a 1,000th of a second.
Okay.
Yeah.
Cool.
Okay, I'm going to also just stick a console.log here. I'm going to go before timeout like this. Okay, something kind of like that. So I'm going to run this now. I want you to watch what happens. You see that there? It did before timeout. It waited a second, then it logged after timeout. I'll reload it just so you can watch. Keep an eye over here on the logs. Before, after. So we did it. We did the thing. That's cool. Okay, why am I going down this path? Because probably like, Ryan, why are you talking about timeouts? This is supposed to be fetch and HTTP and all that stuff. I know, but this is important because the way that this code runs is counterintuitive to how people naively often think it runs. So I'm going to add a couple more logs in here, and then we're going to sort of trace through what happens. And it's going to be maybe surprising to some of you. So I'm going to go, actually, I'm going to go, hello, world, fancy, something like that. Okay. So I've got 3 words I'm logging out. 1 before the set timeout, 1 after the set timeout, and 1 in the set timeout function. Now, reading through this, it's often unclear to people the order in which this code runs. Because set timeout is what's called asynchronous. So this is the opposite of what I used before, that word synchronous up here, where we're talking about these functions sort of return things immediately. Set timeout's a little different. Like you'll notice that like I'm using it, but like the code in it isn't running until later. And this notion of like code that you're sort of like telling to run in the future, this is a thing that's called asynchronous, where the opposite, synchronous, is like I'm saying this code should run now. So I'm going to save this. And what you're going to see is it goes hello world fancy in that order. Why does it go in that order? Well, let's sort of skip by the stuff at the top because this is all synchronous, and I think you all understand that part. So we're here. Okay, get to here after timeout. This runs. Okay, cool. We got our new function called after timeout. It's sort of stored in sort of the JavaScript sort of state. It knows the function there. Okay, it gets to line 20 here. Okay, console.log hello. Okay, so that's the first one. Hello. Set timeout. Okay, so this function gets called. This is where things get a little bit tricky. What it's going to do then is it's going to take this function. It's going to say, okay, in 1,000 milliseconds, run this function. And this function's up here. Okay, no problem. Cool. So it sort of sets that up in the future to run, sort of makes a note to itself in 1,000 milliseconds to run. And when it gets down to this holding area, it'll then sort of spin around and it'll run that. Okay. Line 22, world. Okay, so it's going to log that out. That's the next one here. Then it's going to go down to our holding area. It's going to start spinning around, spinning around, spinning around. Keep going, keep going, keep going until eventually a second goes by. And it says, oh, okay, it's time to do that event thing, the event that the code told me I needed to do. And then it calls after timeout. And then now you get fancy logged out. And then this ends, and sort of it goes back down to the holding area, and spins around some more. And here we are. We're just sort of like it's spinning around. That's sort of what it's doing. It's sort of waiting for the next thing to happen. And yeah, that's sort of how that ends up going usually. Now, before I keep moving forward, any questions? Generally, am I making sense? Let me start there. Can I get some thumbs up in Slack if I am, or thumbs down if I'm not? And totally cool to say if I'm not. Artrell, you got your hand raised.
Yeah, I got a question. So
Yeah.
the 1,000 millisecond, that delays it slower than the normal computer function?
Yeah. So this code here, this function is being run at in 1,000 milliseconds. So like an event is triggered in 1,000 milliseconds that will then cause this function to run.
Okay. The way I was looking at it, I felt like it should go in order, like fancy hello world. But I'm still kind of confused about the after timeout, because if it's delayed more than it would normally compute, would the hello be last, or am I totally missing that concept?
No, I think you might be missing it here. So
Okay.
After timeout is defining a function. If I get rid of these lines down here and just run this, you're not going to get any logs. This isn't running a function. This is like defining a function. And then I could call here after timeout, and then I'd get fancy logged out. But on its own, this isn't doing anything. And if I do this, I come out those lines down there and I run this. Now you're going to see hello get logged out because that's sort of there, but nothing's going to happen with fancy because that's in the after timeout. Like, I can still run it here, but it's just not going to do anything on its own. What the set timeout will do is it will run this function in 1,000 milliseconds. And why that's important is that it's not running it immediately. So let me do the opposite to this, is if I just did like after timeout like this on its own. So I'm going to comment out this line down here. So now we've got like hello and fancy, like they're sort of being run in sequence. You sort of get hello, then fancy, because calling this line, oh, okay, time to call this function. You jump up here, hello, or fancy, and then return, come back down here, go down, you're good. And if I stick like this here, the world at the bottom, like now you're going to sort of get all three in hello, fancy world in that order. But
Okay.
when I switch this out, this is now delaying it. So now this is going to be afterwards by 1,000 milliseconds or a second. Does that make more sense?
It's starting to make more sense. Starting to
Okay.
make more sense because
Cool.
the fancy is going to kick in after the timeout.
Exactly.
So that's going to be the last one.
Yep.
Okay.
Cool.
Thank you.
Sweet. Yep. So I saw a lot of thumbs up, so I'm going to keep generally moving forward here. So let's say that we were doing something in the timeout, like some sort of thing that we wanted to sort of return. Like we were calling this function and we were like, I don't know, this is going to be very contrived and I apologize in advance, but like I had something like, I wanted to return like 5 or value, whatever. Very contrived, but I've got this variable here. I want to get this variable and I want to return it. Like I want to sort of get it, like I want to be able to do something kind of like this and like get this value to come out here. So you can't really do that with set timeout because like you're not calling after timeout. Like another thing is calling after timeout. You don't have control over like the return value. Like here, you're just saying like just giving it the function. You're not actually calling this function. So you don't ever get the return value to come directly out of it. And this is like kind of makes this whole thing really hard. Like, how do you do this? Well, the way you do this is you don't return it. You do something else, but that sort of accomplishes the same goal. And that's something called a callback. Now, you might have heard this phrase before. Maybe you have, maybe you haven't. But this is another sort of thing that you run into in JavaScript quite a bit. In fact, this after timeout is kind of a callback. So this is the why they call it a callback is a function that is run by someone else to give you data back to your original function. What does that mean? Well, we've got the set timeout here. This set timeout calls after timeout. I'm not calling after timeout. Set timeout or JavaScript behind the scenes is calling after timeout. So therefore, it's calling back into my code once this time has passed. So if I wanted to get a value out of this function into some other place, I could do the same sort of thing. What if I defined a function up here that was like other or like return function or something like that? And return function like this is the return value. Something like this, and then return value, something roughly like that. Okay, so we made a function, it logs out a thing. And then instead of doing a return here, we do something like this. So the idea is instead of returning, we can call, like, if we, let's say before we were going to do like const value is equal to this, and then to sort of do something with value here. Instead of doing the thing with value here, you do it up here. Okay, let's walk through this. So what this is going to do, I start here. Okay, defining a function, cool. So it stores that function for later, no problem. Oh, okay, define another function again. Okay, stores that for later, no problem. Gets to here. Okay, logging out hello. So it does that. And then this is a comment, so it skips over that, and then sort of goes to here. Okay, set timeout. Okay, cool. So this is going to register a function to run after this amount of delay. So it tells JavaScript, okay, in 1,000 milliseconds, trigger an event that'll sort of run this function as like a handler on that event. Okay, cool. So it registers that for the future. World, okay, logs that out. So you get hello and world in a row. Then you go down to the holding area. Okay, then you're sort of waiting, you're spinning around, you're in your infinite loop, just sort of staying there. And then a second goes by and okay, cool, time to call after timeout. So it jumps up to here, logs out fancy. And then sort of we somehow get this value. I just stored it, set a value here, but assume you do some sort of computation with that value and you're doing something with it. Okay, cool. And you say, okay, so I want to return that out, but instead of returning it, you call this function. And this function then, now inside of here, you can do whatever you want with that value. And what this lets you do is sort of effectively run code like after the set timeout is done, like behind the scenes. And you might say, like, couldn't you just put it in this after timeout function? Yeah, you could. But the point I'm trying to demonstrate here is like, you can sort of decouple things in this sort of way, where if you want to return something out of this, the way you would do that in sort of this async kind of workflow is by using a callback, making another function that sort of your function calls. And what you end up with here, effectively, you can guess, is like a series of functions where you have async code, like an after timeout that gets run not by you, by JavaScript somehow. And then sort of to get a value out into a parent context, you can't do that. So instead you go one context deeper. You go to a child context, sort of has the stuff you want. So this is like a child context, like within that after timeout. So you've like gone after timeout and you're going to like another function. You sort of can keep going down that path. And what ends up happening is you never really return for any of these functions. Like the return value becomes meaningless. Like the thing you're doing is you just call another function to return. And this sort of pattern is called the callback pattern, and you're going to see it all over the place in JavaScript. You also just see it all over the place anytime you're doing async programming in kind of any language. But JavaScript, you don't really have a way to escape from it. Like it's just sort of how things work. So you're sort of stuck in this paradigm. Okay, cool. Before I move on, any questions about what this sort of async thing does, or like what a callback is, or anything like that? And I apologize if I'm kind of moving somewhat slow and sort of covering things over and over. I just want to like make sure I'm getting everybody here and I am not leaving too many people behind. I don't want to keep plugging forward. So
I guess I'm having a little trouble with the
Mhm.
like when you mentioned the concept of like callbacks, they never really return anything, right? Like it's just like a loop. But unless I'm understanding it wrong, like a callback uses the return value of the function before it, right? Or am I understanding that wrong? Like what is the so I kind of gave you mean like the loop of functions, like what are they transferring to each other? Like, and I know
Yeah.
you probably explained that, but I guess I'm trying to conceptualize like what's being passed on if they're not returning anything.
Yeah,
Unless you mean
so
like they're not returning anything outside of that.
they're not returning anything outside of that. Yeah. So the term return in this context is sort of ambiguous because it sort of has two definitions. Definition one is like the actual syntax, like return space thing. These two functions are not returning a thing in that notion of returning. There's no sort of return keyword. However, conceptually, these are functions that when they're done, they take the value that they sort of calculate, I guess after timeout does, and sort of gives that to somebody else to do something else with. In that notion of return, that sort of like conceptual notion of like this function takes parameters and returns a result. These are returning something. It's returning by calling another function instead of returning by like actually returning using the return keyword. Does that make sense?
It does, and I think we kind of went over a little bit in the last class. Is that like kind of what the response? Remember we were going over the like the async functions then, like, and we had that response variable that was just like after the.
Yeah.
So that is that kind of serving as like what would be passed on to the next function, basically.
Brian, we're gonna get to this in like 20 minutes. Chill down for a second.
Okay, all right, my bad, my bad.
No, you're good. You're totally right. Yeah, that's what we're doing. So you probably can guess, but fetch is also an async operation. But we got a couple stepping stones to get to before we can get to fetch. Okay. So we've talked about callbacks, but there are some problems with callbacks. And I think in order to demonstrate the problems, I want to sort of show you a little bit more of a complex example of what you can do with a callback. So what I'm going to do is I'm going to write some code that's going to log out a bunch of things like hello, wait a second, like world, wait a second, another word, sort of word by word every second. And you're going to see what this looks like. And we're going to sort of walk through this code, and it's going to be an interesting experience, I think. Before I do that, though, let me take this code and let me copy it. I think this is complex enough where it'd be good to reference back to. So let me go into here. Actually, let me go. Okay, something kind of like that. Cool. Okay. So because I've got all that copied over, I'm going to get rid of all this code and we're just going to start from scratch here. Actually, I'm going to keep the holding area down there because that's kind of an important thing. Okay, so I'm going to start by console.log. I need like a theme. I'm going to go with fruit again because that was like very easy. I promise I don't just have a thing for fruit or something. It's just what comes to mind to me first. So, okay, set timeout. Now, before I defined a separate function, like I defined a function above and did like cost the function is equal to the thing. Going forward, I'm just going to define the functions inline because it's going to be a little bit faster and easier. And that's typically the way you do it. So instead of doing like set timeout, like my function, like delay, like this, I'm going to do like an arrow function in here. It means the same thing, but like just want to call that out in case that confuses folks. So now I'm going to log out another thing. So banana. Now I'm going to do another set timeout. I'm going to log out like pineapple. I think it's got an E in it. Something like that. Okay. Wait there. Okay, we're going to do one more here. This time I'm going to go mango. Okay. Okay. So this probably looks pretty overwhelming. But let's go over here and run this. So apple, banana, pineapple, mango. So waited a second between each one, did what we wanted. Let's walk through this though, just to make sure it's very clear what's going on here before we sort of pick this apart. Line 8, so this is sort of where we start, console.log apple. Okay, no problem, that should make sense to everybody. Then set timeout. Okay, so this sort of is the next function that runs. This sort of set timeout here. So this closing parenthesis down here goes to this opening parenthesis right here. So this whole thing, like, is the function that's run. This is the first parameter of that function. So it sort of starts here and ends here. And this is the second parameter of that function. Okay. So it's going to run. This is going to say, okay, cool. So in a second, I want to trigger this function to run. And it goes down to the holding area. So it spins around and waits and waits and waits and says, oh, okay, it's happened. We've got 1,000 milliseconds have gone by. Okay, go into the set timeout. Okay, now it console.logs banana. Okay, cool. So it does that. We get our banana, and then it comes into here, set timeout. Okay, get another set timeout. Cool. So then it's going to run this. So this is the opening parenthesis right there. This is the closing parenthesis right here. So sort of go together. This is the first parameter, or I guess technically this is the first parameter of the function. So starting with this parenthesis here and the closed curly brace there, that's the function it's going to run. And this is the second parameter. So what's going to happen is it's going to say, okay, schedule in the future in 1,000 milliseconds for this function to run. And then it's going to return like done with the function return out of this function and go back down to the holding area. Okay, waiting. Oh, okay, 1,000 milliseconds have gone by. Okay, run this function. And you're sort of starting to get the pattern here. We're like, log the thing out. Okay, now this set timeout's going to run. And this is sort of the function that's going to get scheduled to run in 1,000 milliseconds. And this is the amount of time to wait. And then it's going to be done. So it's going to return and it's going to come back down to the holding area and spin around, console.log mango, and then we're done. So that's sort of, yeah.
Can you run the function? Can you run it on the console log, on the console, on the computer on the other page?
Yep.
Yeah.
So I'm going to reload this page and keep an eye on what happens here. Apple, banana, pineapple, mango.
Okay.
So notice there's a second time lag in between each of those.
Mm-hmm.
But so I guess before I move forward, like at least at a high level, would I walk through there? Did that kind of make sense? Or do you want me to do that again?
No, that was a great example. That was it was a much clearer example than the ones prior.
Cool. That was I guess the reason why I'm bringing this up is because the stuff is not super intuitive. Like code's running often in a different order than you think it's going to run. Like you look at this and you're like, I wasn't doing a lot of top to bottom. I was doing a lot of like that, like back and forth around thing. And that's like kind of That's not how people normally think about code running. Like it makes a lot more sense if things just sort of go from top to bottom. So that's why I bring it up, because if there's any, like, this is one of those things where, like, with this material we're talking about today, if you get lost at a certain point, you're going to have a very hard time figuring it out again until you go back and sort of figure out that earlier part, because it all builds on top of each other. But anyway, so, okay, we've got all this, but what you'll notice about this code, it's like, let's say we had like 10 set timeouts in a row here. We want to log out 10 words. You're noticing that because I'm indenting my code, it's sort of going to the right quite a bit. In fact, it's almost going to the right about as much as going down. Like the ratio of sort of lines of code to indentation is kind of absurd here. Like it's just sort of like marching to the right. And this is a problem you run into with callbacks, where you sort of have the situation where, like, when you have callbacks instead of callbacks instead of callbacks, you have a lot of indentation levels, and your code starts to go more right than it does down. And if I were to like get rid of these console.logs, it would become a lot more clear. Like 1, 2, 3, 4, 5, 6 lines, and we have 3 indentation levels. And if I just sort of keep doing this here, like it's really like this. I mean, you're probably thinking, in practice, how many times would you be doing this? Like, this is crazy, but you'd be surprised. You have these sort of things where, like, every time you want to return from an async operation, you've got a callback. Like, it's not so crazy to call like 6 functions in a row. I mean, it's not something you maybe would do everywhere, but like it happens. And if you're doing that, like now you sort of have to reason through all these callbacks, all these different, like, it's just like, it's not that easy to follow. So there's this concept that this is called, like, the term that's often used here is this thing called callback hell. It's like a term you can look up. And it's just when you're sort of thinking in like callbacks and not in like how code runs like top to bottom. So why am I bringing this up is because why I'm bringing this up is because there's a solution to this problem. And the solution is what's called a promise. This is where we start to reconnect with what we talked about on Thursday, or on Wednesday. Thursday, Wednesday. That's the day, Wednesday. Okay. I'm going to, before I talk about promises, though, take this code and post this in the chat, just so that people have it. Yeah, there we go. Okay. Cool. Okay. So, what is a call, or what is a promise? So the problem with async code, as we talked about, is you can't really return from a function that's called asynchronously because you don't have control over where it's called. So if it's called by something that you can't like update, then you can't get that return value out of there into your code. So the way you get around that is use the callback. But, and this is like a big thing, like these callbacks are hard to read. So what if there was a way you could actually return from an asynchronous function? Like, let's just sort of like think through this conceptually here for a second. Like, what if you could do a thing like be able to return from like an async function, and then sort of like the thing you're returning sort of like later on, like that code would run like after that thing's done or something. So like imagine I could turn this code into something more like this, where like I set timeout and I like log out. Oh, come on. Okay. And do something like that, where I log that out like that, and then maybe down here, I'm like, okay, like sort of more reading it the way your brain thinks it would work. You know, I mean, this obviously wouldn't work because like I'm making all these set timeouts that are empty, but like, imagine you could write it this way. Like, wouldn't this be so much easier to understand? And a promise sort of lets you do this. But like, we can't break the rules here. Like, we still have like this whole, you have to have these functions that like get called. Like, you can't return things from async functions. So like, how do we do this? Like, there's got to be a way. And the way is that a promise will allow you to have multiple, how do I explain this? Gosh, this is where my explanations fall flat a little bit. A promise allows you to, instead of returning a value from a function, to return something that then later on a value gets put into that thing. This is where I was talking about on last week, the whole like the empty boxes that gets filled later thing that I mentioned. But think about it like this. You've got the set timeout. In here, we've got our value we sometimes calculate, okay? I'm gonna get rid of all the stuff down here because I just want to make this simpler. And we somehow want to get this value, like we want to be able to log it out down here. And obviously this isn't going to work. We can't like return value or like that's not going to happen, but we want to get it down there. So what if we did something instead where we made a variable up here called value, okay? Like a new variable up there, and we like assigned it in here. We didn't make a new variable, we like assigned the variable already up there. Okay. And then we could then somehow later on here have some code that would be like, wait for value to get filled. And then once it gets filled, you log it out. So thinking through this like pseudocode, keep in mind, this isn't actually going to work what I'm typing here, but like we're sort of moving in the direction of promises slowly. What's going to happen here is line 10, we define a variable value. Set timeout. Okay, so we take this function here, we schedule it to run in the future, wait 1,000 milliseconds for that to run. And then we come down here, we sort of wait for the value to get filled, and we sort of spin around, we wait for it for a thing to happen. And then, oh, timeout runs. Okay, cool. We've got this value here that gets set, value becomes 5. And then now the value is filled, this code down here runs. And now it's able to log out 5. Like that's a way we could do it. And like it still isn't quite exactly the super simple thing we laid out, but it's a lot closer. Okay. Let's say now so I can't actually run this to sort of show it to you because this isn't real code. But what if we were to call this value thing a promise? And why it's called a promise is promises. If you like, let's say I'm like talking to you and I say, I promise I'm going to like go take a walk today or something like that. I'm sort of making an agreement with you. I'm saying in the future, I'm going to go take a walk. Like that's a thing I'm going to do. And I can, at some point in the future, once I take that walk, I've fulfilled that promise. I've like done the thing that I said I was going to do. And that's sort of what I'm doing on line 12. I'm like saying, oh, okay, I did that promise. I sort of filled it up. Like it's no longer sort of in like a limbo state. It's sort of like occurred. Things happened. So I guess if I'm going to update value, I got to update it down here too. Promise. And this is called resolving or fulfilling the promise. In addition, though, it's possible to do what's called rejecting the promise. And rejecting the promise is like breaking a promise. It's like, oh, actually, I'm not going to take a walk today. Sorry. But it's like, instead of it being like in a limbo state where you're not really sure sort of what the future holds, you're now saying, for sure, this is not going to happen, or for sure, this happened. So that's what's sort of hard about promises to sort of wrap your head around in my understanding. It's like promises represent a value that will later on exist in the future. Just like I might promise to you, like the act of promising I'm going to go take a walk, that's a thing I can store. But then that promise itself later on can then sort of be fulfilled or rejected depending on the outcome of that asynchronous thing I said I was going to do, taking a walk. How am I doing? Hopefully good, maybe.
So is the value the thing or the promise?
The value is the I guess when you say value, do you mean?
So using your example of the going on the walk, right? So I get what you mean. Like say you're at 8 a.m. You tell me I promise I'm going to take a walk today, right? You know, until the end of the day, that promise is like unfulfilled, but it's not fulfilled, but it's not fulfilled, right? You still have the rest of the time to do that, right? If 12 a.m. hits and you haven't walked, now that promise has been rejected, right? Because you have now walked today. If you walk anytime before that, the promise is fulfilled. So you're saying that the value is either the fulfilled or the rejected. It's not the walk. It's not saying like, oh, the walk happened. I'm returning some confirmation that the walk happened. You're basically saying that the value is rejected or fulfilled.
Correct. But
Okay.
if we're talking about the promise, let's say I make like 3 promises with you. We need to somehow come up with some sort of way we can talk about which promise we're talking about. Like promise 1, promise 2, promise 3, you know? So the value promise, like on line 10 there, like that sort of what that value is representing is like one of those promises. But a promise itself within it can be resolved or rejected or fulfilled or rejected. So they are very much 2 distinct things, but I think you got the breakdown right. Cool. Any other questions? Okay. I'm not seeing anything, so either that means I've lost a lot of people or lots of people are getting it. How about this? Give me a thumbs up if you're understanding it. Generally. And if you don't have to have it perfect, but just like roughly. Okay, cool. I'm seeing a decent number of thumbs up, so I'm going to keep moving forward, I think. So how do we actually do a promise in JavaScript? Well, I think we're going to sort of do this kind of the reverse way that it normally gets taught, because I think it's actually going to maybe make more sense from this entry point. But there's a thing in JavaScript, a built-in thing, just like set timeout, just like console.log, a built-in thing called promise, uppercase P promise. Now, actually, before I go down this path, you folks haven't learned about like classes yet, or objects, or I guess you talk about objects, but if you talk about classes, does that ring a bell? Okay, I'm seeing some head nodding. So like you've heard of like the new keyword, like if you did like new something, like to make an instance of a class, like that's.
We haven't really done it in class, but we've done it in the free code camp exercises. If
Okay.
anybody can kind of, that should give you an idea.
Okay. So then I'm going to type this, and we'll sort of hand wave over it then, because it's not all that important for this, but those who understand what's actually going on, that's probably going to make more sense. Okay. So I've got this value here, promise. I'm going to actually do this how I would actually do it in real JavaScript now. So before this was just pseudocode. Let's do that for real. So if I wanted to do this in real JavaScript, where I sort of like waited a second and then have a promise that was sort of filled with the value 5, and I sort of log it out when I'm done. This is how I would do that. So I make a variable here called promise, and I make this new promise thing. Now this new keyword, if you don't know what this is, just effectively think of this promise as like a function I'm calling, and it's just like a special way of calling that function. Now promise itself takes a callback as a parameter. So I've got a function that I'm passing it. And this function has 2 parameters within it, resolve and reject. So what promise is going to do here is when this sort of function gets called, it's going to call my callback, very similar to how set timeout worked, where it'll call the function that's passed to it, but it will then call it with 2 parameters, resolve and reject. And what this will do is sort of kick off our promise. So in here, we're going to sort of do our initial logic. So I'm going to stick my set timeout inside here. Okay. So when this promise runs, it's going to, or when sort of the code hits this, I should also say like, this is technically asynchronous, but it's going to run this right away. So you can think of this almost like a set timeout 0, with like waiting 0 time for this to run. So it'll sort of run immediately. Okay, so it'll run this. It'll be in here, and it'll call this set timeout. It'll see, oh, set timeout. Okay, cool. So then it'll see this, and it'll sort of schedule this function to be run in 1,000 milliseconds. And it'll sort of get to the bottom, it'll jump down to the holding area and sort of wait and wait and wait. And then once that 1,000 milliseconds comes by, okay, it'll come up to here, and it will like do the thing to be done. And like this is sort of where you want to like do your return equivalent. Now the way you return this in this sort of context is this is where these functions come into play, resolve and reject. So resolve is itself a function. And this is like, I should say also, like, there's a lot of functions at play here. So we're going to run through this again just one more time to make sure everyone gets it. But I'm going to call resolve and pass it 5. So what I'm doing here is this resolve here, this parameter is itself a function. And this is almost like returning. I'm like calling this function and saying, return from this promise with the value of 5. Cool. Now, if I log out this promise, log out this value, I'm going to see something looks like this, a pending promise. So it's sort of pending. This is like it's sort of like the promise hasn't been fulfilled, it hasn't been rejected, it's sort of just waiting for it to happen. And the reason why it's pending is because this is being logged out right after the promise gets set up, and the set timeout hasn't run yet. So like it's logging itself out, and it's like nothing's happened yet. It hasn't resolved, it hasn't rejected. Okay. But this is to solve the problem, like how do we get the value out of that promise again? Like we haven't done anything here yet. You're probably like, what's the deal here, Ryan? How's this going to work? Well, promises have this method on them called .then. We talked about this on Wednesday. This is a really important way you interact with promises. And what .then does is it sort of lets you unwrap a promise and get access to the value within it. You can think of it like it's an event that fires when a value shows up inside of that promise. So that promise becomes fulfilled. So if I go promise.then, it's a function. Inside of .then, it takes a callback. And this callback will run when the promise fulfills. So I'm going to go like value here. And then I can, if I wanted to log out value, I can do that. So let me run this and I'll sort of walk through this code line by line and talk about what's going on again. So I see Apple sort of at the beginning here, and then I wait a second and I see 5. So Apple, wait a second, 5. Now notice I'm not seeing promise pending or promise fulfilled or promise rejected. I'm seeing the value inside of the promise. So this is where that breakdown comes in. Like there's the value inside, and there's the promise itself, and those are two different things. You can have multiple promises going on at once. So that's why you need to be able to keep track of which one you're talking about. And different promises can be fulfilled or rejected differently and at different times. So, okay, let's walk through this code sort of line by line. So log out Apple, whatever, that's straightforward. Okay, get to line 10. Let promise equals new promise. So what it's going to do is JavaScript's going to run this line of code, this whole section here. And this new promise thing behind the scenes is going to run this function. Okay, this function runs. It gets passed 2 parameters, resolve and reject. Resolve is a function, reject is a function. We're not going to use reject for now, but they sort of both act very similarly. So now, okay, we're inside of this function. We're going line by line. Okay, here's the first line, set timeout. Okay, so set timeout's going to take a function and sort of schedule it to run in the future. So here's the function I'm going to schedule to run in the future, and here's my timeout. So it's going to schedule it to run in the future. Okay, no problem. I'm going to sort of return the keyword return out of this function. So sort of come back and then return out of here, and sort of it's going to return back. This whole expression is going to return an empty promise. So now what I have, by the time I'm sort of done with this section, I've got 2 things. I've got an empty promise stored in this value here, and I've got a function, this function, that's scheduled to run in 1,000 milliseconds in the future. Okay, line 15 is empty, line 16. On line 16, I'm calling this .then method on the promise. And I'm passing to this .then method a function, a callback function. What this is going to do is it's going to, inside of the promise, store this function and say, once the value shows up in this promise, once this promise becomes fulfilled, call this function and sort of let me know. And then it goes down to the holding area, sort of waits and waits and waits. And we've only got one thing that's sort of scheduled to run in the future, our set timeout here. So we're waiting for that second to pass. Okay, that second's passed. So this function now gets called by JavaScript. Okay, JavaScript goes in here, it sees, oh, resolve 5. Okay, cool. So it's going to call this resolve function, which is part of sort of the promise implementation behind the scenes. What's resolve going to do? Resolve is sort of built into the promise. And behind the scenes, what resolve is going to do is it's going to resolve that promise. It's going to put a value into that promise. It's going to sort of say, I will have taken my walk for the day. So you're going to complete that transaction. And once it does, a value is going to be in there. And when a value shows up, it's going to call all the functions that have been registered with .then. And so it's going to call this function. And it's going to pass it that value. So effectively, you can think of this function here as being like resolve. So when I call resolve, it's going to call this. And the sort of the way that's hooked up behind the scenes is this is stored inside of the promise. And this is also stored inside of the promise. So like you're calling a thing that's in the promise and you're registering a thing in the promise. And once sort of resolve gets called, this gets called here, then I'm going to log out my value, log out 5. So 5 goes to resolve, pops out here, logs it out. And then we're done. We go back down to the holding area, we sort of spin, and we're just sort of there forever. And that's our program. What do you all think?
I think it makes sense hearing it. You need to practice it.
For sure. I will say that in general, the level of detail I'm showing you here is not really what you need to know to use a promise. I'm giving you all this information mostly so you can understand it. And feel free to give it a try on your own. But also, like, if you can't get the syntax exactly right and sort of figure it out exactly, like, that's okay. My goal here is more to just give you all the context you can sort of like think through it. Artrell, you have a question?
Yes. If reject had a value, would it have console logged out?
Good question. So if I did like reject here instead of resolve. That's what you're asking?
Yes.
Okay. Yeah, let's do it. So I think I showed you what happens here. So we get the 5 there. Let me do reject. So you're going to see this thing that says uncaught in promise 5. What's going on there? Well, there's a little bit of magic going on behind the scenes to make what's going on here happen. But effectively what reject does is the other side of the promise. So I told you, like, I can go for like I can go for a walk example seems to be hitting pretty well. So like if I promise I'm going to go for a walk, and then I go for a walk later in the day, I've resolved that promise, I've fulfilled that promise. But if I decide to not go for a walk, that promise is rejected. I didn't actually complete that promise. And it's no longer in limbo. It's like officially in the no column, as it were. And that's what this reject function does. You can reject with a value. So you can sort of like return negatively. I would say, like, if this is a helpful concept, think of resolve like returning, and think of reject like throwing an error. Conceptually, that's how it gets used most often. What that means is .then, you're not going to get that. That's not going to be called with the reject. There's actually another thing you can do, promise.catch. And this acts just like .then, only will happen when you get a promise that's rejected instead of resolved. So if I did something here like console.log reject, and then value, something like this. So I'm going to see reject 5. Still going to print this out because I have some stuff turned on that's a little bit fancy, but you see, like, it's calling that code. Yeah, so that's sort of what happens with reject.
All right, that makes sense. Thank you.
Yeah. Any other questions?
I have a quick question, and it might be something you're going to get to, but how does the promise know, like, that what the function inside it returns should be resolved or rejected, right? Like, so in this example, like when you use the resolve, you put like the 5 in it, so it's almost like it's forcing it to resolve, right? But
yeah.
I would imagine, like, in some cases in the future, we'll get a return from that function that maybe we can't anticipate, or like we don't know what it is. So like, is there a way to set up to like tell the system like resolve with these returns or reject with these returns.
Yeah, so it sounds like kind of what you're getting to is like, what if you have some synchronous code that returns and never calls resolve or reject?
Or
have
I'll
that right?
say, I'll say, what if it returns? How does it know that that function is a resolve or a reject, right? Again, like sticking to the example, when you took out the resolve and you just basically, because the dot then serves as basically how to handle a resolved value, right?
Mhm.
But I guess reject would be if whatever function comes before the dot then, if that ends with anything other than a return, I guess. Does that make sense?
I don't know
Like
if I'm following you. Sorry.
Okay. So here's how I should say this, I guess. All right. We can confirm that some returns should be resolved, right? And some can be rejected, right?
If you return from this function, like if I'd returned 5, that's going to do nothing. Like,
Well, okay. So maybe I'm using the wrong terminology. When you had resolve up there before, like where you have reject now, right? When you
Yep.
had resolve 5, right? You're basically telling it that like 5 is going to be in there, right? So
Yep.
it's almost like I imagine, I guess I'm trying to anticipate. I see the reason for resolve and reject is basically giving the system like some way to handle like the absence of a value until it's there, right?
yeah.
But
So
in anticipating, I just don't, maybe you'll explain as we get further. I don't see how we can, besides telling it that 5 is resolve and I guess anything else is reject, how else would it know, to that, oh, whatever it returns should go to then as opposed to reject.
I see. So if you use the resolve function and you call that with a value, it'll always go to then. If you use the reject function and you call that, it will always go to catch. There's no sort of like filtering based on value around where things go. Like the function you use defines where what gets called here. Does that answer your question?
I mean, kind of, because like, what would you do if you don't put resolve explicitly in the function above?
So
right?
like, what if I did like, you're saying like, what if I commented this out? Like what would happen then is what you're asking?
Right.
Okay, this is a good point. Well, let's give it a try. So I'm going to run this. So waiting. We can wait here forever. Nothing's going to ever show up. So this promise is permanently in a limbo state. It never resolves, it never rejects.
Okay. What if you put just like a value? What if you just put like, I don't know. I guess maybe I'm asking it wrong, and I'll just hold off until like we get ahead because you may explain it like in a different way as we go forward.
Okay, fair enough. Yeah, but please interrupt me again if I don't cover what you're talking about.
Will do. Thank you.
Cool. So any other questions about promises before I keep moving forward here? There's one more thing I'm going to cover before we're going to get back into fetch again. Okay, sweet. So you might be asking like, okay, Ryan, look, we just talked about how this is supposed to reduce callback hell. I'm starting to see this sort of thing going on here again, like indentation levels. Like, what are you talking about? Like, this isn't helping. And it is kind of is to some degree, like you're stretching. This is not a callback, like inside of another level of indentation right here. So you sort of gotten this callback out from inside, sort of back out at the root level again. And it turns out that that's actually the most important thing this does for this sort of readability problem. What this will do, so let's say I have in this function here, I have like another value I want to do. Like maybe I have like another sort of thing. I want to have like another callback, another async operation I'm going to do. So I do like set timeout. Maybe I wait like maybe orange this time. I'm gonna wait like 5 seconds for this one, something like that. Okay, so that should probably make rough sense to you. So do that, get 5, wait 5 seconds, and then we're gonna see orange. There we go, orange. So cool, okay. What if I want to return something from this though? Like, I guess I could do this whole dance again with like the promise like this, and Yeah, I mean, let's go through it. Let's sort of give it a shot. Let's sort of go through the exercise. I'll explain why this is the power of promises here. Okay, so we're gonna do this. I'm just gonna how am I gonna do this here? I guess I'll do resolve orange this time. So R-A-N-G-E. There we go. Spelling is hard. Okay. So we've got our I'm going to call this promise 2 also, just to sort of disambiguate it. So we've got our promise 2 inside of our original promise then here. And I could log this out. And as you might expect, I'm going to get like a pending promise because it hasn't sort of waited the 5 seconds. So it's going to be pending, not have a value in it yet. But like, I mean, if we wanted to sort of, like, yeah, let's go through the whole exercise. So we go promise 2, then value 2, console.log value 2. Okay, cool. So we've gone through all that. Apple 5, pretty much do the same thing here. Later 5 seconds. I should have done less than 5 seconds. Orange. Okay, this is pretty much the exact same code I did here. Like this is sort of the set timeout example where I sort of had like the outer set timeout and the inner set timeout, and sort of the nesting set timeouts all the way down. But I'm doing this with a promise because there's a cool thing about promises. And that's, and I'm going to say this a few times because it's going to sort of takes a second to wrap your head around. This function in here, if you return a value from this function, and by return, I mean like literally the keyword return, like proper return, then it will take this value and it will turn outer then here a new promise that contains the value returned from the then function. I'm going to say this a few times because it takes a second to wrap your head around this. If I return a value from this function here, so if I do something like return 1, 2, 3, this entire expression will evaluate to be, like if I stick this into a variable, promise 3 or something, this variable will now be a promise that will eventually contain the value 1, 2, 3, resolve to the value 1, 2, 3. So you can think of these as almost like, imagine I make a promise that's dependent on another promise. Like I say, I'm going to take a walk after I go to the gym. So in order for that to work, the gym promise has to resolve first. And once the gym promise resolves, this then function gets called, or I guess this function gets called. And this sort of does the walk part. And then maybe the response for my walk is like I'm counting my number of steps or something. That's sort of like a number of steps I took. And that's sort of the end result of the whole thing. And I'm sort of returning that number of steps. Now this promise here is going to contain my number of steps. But this promise is only going to contain a value after my like my going to the gym promise resolves. So sort of they're dependent on each other. They have to happen in a certain order. And it turns out like that matches really well with sort of the way you have like line of code. Those lines of code are dependent on each other. Like the first line of code has to run, and then the second line of code has to run. And the second line of code might depend on things on the first line of code. So you sort of have to run them in that order, and that's really important. And you sort of, you're defining like a relationship here between asynchronous things, where they sort of have to happen in a certain order. So let's, I'm going to keep moving here, but before I do, any questions on that I can answer real quick? Okay, I'm going to keep talking then. Let's adapt our example here. And I promise after this, we're going to take a break because we're starting to get to back to that time. And I want to give you all a second to sort of think and process and all that. But let's get to the end of this and then we'll take our break. And then we'll get to fetch after the break. So this thing here, let's sort of adapt this to work in this sort of model that we sort of laid out here at this promise then thing. Okay. So instead of doing this thing here where I'm going to sort of like do this other than, I'm actually going to, let's see, I'll do it this way. Return promise 2. There's one other thing I forgot to mention that is important here, and that's that you can return 2 different things from one of these functions in a then. You can return either a value or a promise. And this is a really important concept. You can do either. And this is really powerful because if I return a promise, then the promise I return is sort of going to get returned out the other end from this function is going to end up here. And the way that works is you can think of this as like, this is sort of creating a promise. Like this thing runs and immediately returns, it gives you back an empty promise and holds onto a copy of that promise. And then later on, once this then fires and this function runs, the return value from this function, the synchronous return value, gets stuck into this promise here. And if this is a promise itself, then it'll sort of wait with the dot then for this promise to resolve before it sticks the value into the dot then. So what it means is you notice that now, instead of having a second dot then inside of here, so like now I'm sort of at 4 levels of indentation, I'm now back at the root again. I don't have any indentation anymore, which was the whole problem we were trying to solve. We finally came full circle and did it. So now that we're sort of at this, we can now do a thing where we can say promise 3 dot then, and we can log out our value down here. And now this log is going to log out orange. Let me walk through this because there's a lot of steps involved at this point. This is like kind of hard to follow, but it's intuitive if you understand the rules and sort of have practice with it. So, okay, go to the very top. We log out Apple. Okay, come here. Let promise equal new promise. Okay, so it's going to call our function here. It's going to call our set timeout, which is going to take this function here, and then in a second, it's going to run that and sort of schedule out to run in the future. Okay, no problem. Cool. Okay, then we come down to line 16. That's going to take our promise here. We're going to do attach this function here, and this function is going to run once our promise resolves, once this promise gets fulfilled. Okay, cool. It's going to take this whole thing, this whole expression is going to return a promise, like an empty promise, and we're going to store it here. So at this point, we have 2 promises. We have this promise, and we have this promise. This first promise has not been fulfilled yet, it's pending. The second promise is also pending. Okay, now we're going to come down here, and okay, we got our second promise here. We're going to say, okay, once that resolves, we want to run this function. We're going to store that for later. And I'm going to comment this second. This isn't all that important, but we'd also could add a cache to it, whatever. You could add another handler if you wanted. And we're going to come down to our holding area. Okay, so we're now in our holding area. We've got a couple things set up. We've got this promise, which is pending. This promise just is pending. And we've got this sort of handler that's been attached to it. We also have our set timeout, which is sort of ready to go. So we've got a bunch of promises sort of all connected together in some crazy arrangement. And then we've got our set timeout at the bottom. And what we're waiting for when we're in our holding area, we're waiting for that set timeout to trigger. And once it does, it's going to be like a cascade of dominoes. It's going to go down and sort of hit all the things all in a sequence. So let's go. So our set timeout resolves. We jump up to here, resolve orange. Okay, that's going to call resolve, which is going to mean this promise now, or wait, sorry, I was in the wrong spot. That was probably confusing. We're in this set timeout. See, even I can't follow this all that well sometimes. We're in this set timeout. So this function gets called here. So resolve, it gets called. It gets resolved with 5. Okay, so resolve, it gets called. Okay, cool. So this whole thing, the promise is evaluated to before. This promise is now fulfilled. That promise has a value in it. Now it's got a value in it. Oh, we got a dot then on it. Okay, so we can run this dot then. Okay, cool. So this function here is now going to run. So we're going to log out our value. Okay, cool, sweet. So then we're going to come down here. Oh, got another promise, promise 2. So I guess this is sort of out of order here now, whatever. So promise 2, okay, new promise. Okay, cool. So we got this function here. Okay, no problems. We're going to take this function. We're going to run that. We're going to resolve and reject. Oh, get another set timeout in here. Okay, so set timeout, we're going to schedule that in the future. So in the future, this function is going to run in 5,000 milliseconds in 5 seconds. Okay, cool. Okay, so we've got sort of three promises going on right now at this point. We've got our original promise, which has been resolved. We've got our promise 3, which is sort of still pending, and promise 2 now, which is sort of a new thing, and that's also now pending. Okay, now we're going to return promise 2. So what that's going to mean is the promise machinery is going to say, okay, this function returned a promise. Once this promise that this function returns resolves, once that function has a value in it, I'm going to stick that value into promise 3. So sort of the thing that this returns, whether it be a value or a promise, that is going to eventually end up into promise 3. And it's sort of ambiguous. You can either return a value or a promise. In our case, we're returning a promise. Okay. And then we go back down to our holding area. We're sort of waiting there. We sort of come out of this. And we're waiting and waiting and waiting. We're waiting for the set timeout to hit. Once this hits and that event fires, okay, this function runs. This function runs. Resolve gets called. We've got another set of dominoes now we can hit down. So resolve gets called. That calls this function here, which causes this promise to resolve. This promise resolves, which because it's returned from here, now the thing this returns resolves, which now causes promise 3 to now contain a value that resolves. So you see, calling resolve here through a series of complicated steps, which you don't actually have to think about and practice all that often, but we're going through here just to make a point, like, is going to result in a value showing up in promise 3. Like, this results in this promise being populated. And now, because this promise was populated, down here, this runs because this promise, there's a dot then attached to it. So this runs when the value shows up in the promise, when the promise is fulfilled. And this runs and it logs out the thing this promise resolved. So orange. So this crazy little machine I put together here, what it's going to do behind the scenes is something pretty straightforward. It's going to log out Apple. It's going to wait a second. It's going to log out 5. So this thing here, it's going to log out 5. It's going to wait 5 seconds. It's going to log out orange. And that's sort of what's going to happen. This is probably the most complex promise example you're going to see in this whole class, I would guess. You don't need to understand this verbatim as I walk through it now, right now. The thing that I would like you to understand, though, is you have a promise, you call then on it, and you get a value that sort of, that's how you get the value out of the inside of the promise. When the promise fulfills, the function that was passed to dot then is called with the value that the promise was resolved or fulfilled with. And that's sort of the most important part, but I wanted to sort of go through this just to sort of give a taste as to the future if you keep going down this path. So I think I'm about ready to take the break now. I'm starting to take a swig of water here. It's a lot of talking, but how's everybody doing? Okay, I saw a thumbs up. Give me some thumbs up in Slack if you're doing well. Give me a thumbs down if you're not doing well. Oh yeah, a mouth open like our troll. That's a good one. Yeah. Okay, some thumbs up. That's good. That's good. Cool. And it's totally not cool if you're there yet, but I'm seeing a lot of them, which is promising. Okay. How can I help you out, Artrell? What's going on?
I think what's throwing me off is the promise 2 and the promise 3.
Okay.
So I kind of get the concept of, the promise then. So the first promise is going to be 5. The second is going to be orange. But the 3, that's kind of what's throwing me.
Yeah. Okay. So I think the key concept with promises is that this function here, the function you pass into a dot then, whatever you return from the end of this function ends up in that in this value out here. So let me do a demo here without the second promise. If I just did something like return 1, 2, 3, like that, and save this and come over here, what I'm going to get is sort of the same thing's going to happen. I've got this promise here, it waits a second, it resolves with 5, and then this gets called. Now I'm in here. This value here is going to be 5. So I'm going to log that out. Then I'm going to return 1, 2, 3. So I just say logged it out there. Return 1, 2, 3. And that's going to end up in this promise here. And this promise is going to end up being a promise that is fulfilled with the value 1, 2, 3.
Okay, because that's the promised value, and above the promised end value is 5.
Yeah.
No.
Or
Yes. No.
this
Okay.
This is 5.
That's 5.
Yes.
Because in promise 1, when it got resolved, the value is 5.
Yes. The value in
Okay.
this promise is 5.
Right.
And here you're calling then on it. So you're getting the value inside of this promise here.
Got that.
So when you log in this out value here, that's going to be 5. And then
Okay.
the sort of rule I'm adding, the thing I'm adding on here in this sort of little stair step we're taking is whatever you return from the value of the dot then, the function in the dot then, this thing here, whatever's out here, the value this whole expression ends up returning or evaluating to is a promise that resolves to whatever is returned in this function. So if I return 1, 2, 3, promise 3 is going to be a promise that resolves to 1, 2, 3. If I return like apple here, this is going to be a promise that resolves to apple. And that means that like later on, whenever I unwrap this promise, I call dot then on it, I'm going to get the thing that is inside of it, that value that sort of it contains that it resolves to. And that's what I'm going to get down here when I log that out.
That's going to be apple.
Yes. So you write, so value here is
Mhm.
5. Value here is apple.
Got it. Got it.
Now, the second stair step on top of that I guess I also kind of took at the same time is that if you return a promise from a dot then function, so not a value like a promise, the dot then will automatically wait for this promise to resolve and take the value that this promise resolves to and put that into this promise. So what that means is if I had a prompt, like imagine, this isn't actually how it works, but I think this is going to be good enough for now. I have like a promise that like contains within it like the value of orange, or not orange, that's confusing, apple. Again, this isn't the proper syntax, but just so I was doing this to like explain the concept. And I did this. Now promise 3 would contain apple. Promise 3 wouldn't contain promise apple. Like you don't, with the dot then, you're never going to have a promise inside of a promise. You're going to have like a, you're going to always have a promise that contains a value. And if you try to stick another promise in there, it's going to wait for that other promise to sort of turn into a real value before it puts that real value in the promise.
Okay.
It's, I mean, this stuff is like really abstract.
I was just gonna say, this is really, I think it'll probably be a little easier once we start like passing useful stuff onto us, because like now it's like we're passing a 5 onto a promise that returns to apple.
Yeah.
I imagine in the future we'll be like taking useful things and passing that on to the other function, whether it be like a link or something or some type
For
of data.
sure. This is very contrived right now. And unfortunately, I can't really, like, we're going to talk about a real use case with fetch, but it's sort of hard to do it with real use cases at the moment and sort of keeping it simple.
I'm not sure if he is feeling confused about the let promise 2 and the let promise 3, because let promise 2 is within the promise 3. So promise 2, the value of that becomes promise 3. So that's probably why he's getting confused, where he sees the promise 2 and the promise 3, but technically promise 3 is gonna do the promise 2. That's the
more accurately, this could be like promise 1 and 2. is maybe a better way of thinking about it.
Yeah, so the answer to promise 2 was becoming promise 3. So it was
Yes.
confusing him of what the answers that are coming out.
Yeah. Totally. So we're sort of at a point where we probably should have taken our break like 10, 20 minutes ago. So let's do that now, just because I'm also hungry and want some dinner. Sorry, folks. But and we'll after the break, we'll do a thing. We'll actually try out fetch using a promise. And sort of we'll do like this has all been contrived stuff. Let's sort of do this for real. So let's come back at like maybe 7:45. That's it kind of makes our break a little bit shorter, but I just want to, we still have a bit to get through here. So I want to make sure we do that. So see you all back here at 7:45. Sorry. I'm so bad at remembering to do that. So as a reminder, if you're running this, you're not going to be able to run it if you don't use the live server. You're going to have some problems otherwise. So what I mean by that is if you were to just double click on this HTML file, it may not work for you. I'm not going to say it won't work. I don't know how your system's set up, but like you should really do it with the live server because then it's going to be guaranteed to work. Why that is a little bit off topic for today's class, but just I wanted to call that out for folks doing this later on, or just if you're running into problems there. I think we're going to, if I don't have any questions, I think we're going to start running through the exercises here. So if you have any questions, now's the time.
Ryan, can you show me how to run that again? Is it click on live share?
Yeah, so you go down here, click on go live.
Hmm.
It should just open it up in your browser for you.
Go live. Got it. Thank you.
Yep. And make sure it works. Check your JavaScript console. You should see a 200 in there. Okay. Actually, before we do the exercise, I think there was one other thing I was going to talk about. Yes. So we talked about this as well last time, and I want to quickly cover what was going on here. So if you remember, I mentioned last time there's this whole like promise within a promise situation where like sort of we had a response, and then this sort of had to like call a thing on the response to get another promise and sort of unwrap that. What's going on there? Well, there are two asynchronous operations that have to happen for you to get the body out of a response. The first is you have to make a request. So that takes time. It takes time for you to talk to the server, have them process your data, come back with a response. The second thing you have to do, though, is once you have a response, it turns out the way fetch was built. It takes some time to be able to unwrap the body and sort of take the data out of the body and give that back to you. And there's some technical reasons why the way they built it, it works like this. But the short version is there's a second promise you sort of have to take care of and use in order to get the body out of the body out of the response. So I'm going to take this code here, and I'm going to take this, and I'm going to put it into my thing here. Freaking VS Code. Making my life hard. Okay. There we go. Let something like that, I think. What's going on? What am I missing here? Oh. There. Okay. So I'm going to run this. And now if I go over back here, I should see. Oh, and I got to update this to be fruit again. Apples, oranges, bananas. So this should sort of ring a bell from our exercise before. So in this case, I'm doing the same thing I was doing before. But then I'm also taking this response and I'm calling a method on it called text. This also returns a promise. This returns a promise that resolves to be the body of the response. So here I've got my promise here. I call .then on it. Now I'm going to take this. I'm going to paste this into Slack. Give that a shot too. Just swap out your text and your HTML for that. It should work for you. And once you've done that, then we're going to start, I think, going through the exercises. Oh, actually, there's one more thing I was going to talk about too. Okay.
Sorry, Ryan.
Yeah.
Share.
Say that again?
Where's the link for the live share?
Oh, I didn't do that. Maybe I should do that. Share. I've never done one of these live share things before. But I know Max does them. Let me do this. I don't know if I can set it up right now because,
Okay, I'm sorry.
but I will. I'll get it set it up in time for next class and figure it out.
And Jennifer, if you need to copy the code, it's in the Slack if you haven't seen it.
Yeah.
Yeah.
I'm looking for it, but I'll look again.
It's the latest message.
Oh, I'm sorry, Ryan. It's
No,
in
go for
student
it.
C4. It's not in live stream. It's in the students channel at the very bottom.
Sorry if I'm doing things different than Max.
And I'm sorry, Jennifer, not students only. It's in student C4.
Yeah, I'm looking there.
I will copy a link and send it directly in Slack to the message here.
Thank you.
Click on that. Okay. So I'm assuming if you got the first one to work, you're probably getting this one to work too. Like it's just copying and pasting code. So if you need, if you want any help though oh, yeah, perfect. If you want any help though, we can sort of work through it some more. So let me know. But otherwise, I'm going to keep moving forward here. So there's one other thing. I know I keep saying one more thing, but I promise this is the last thing because the exercises come right after this. So this is really the last thing. There is a tool I want to show you that I think you're going to find really helpful as you work with Fetch. So you've probably talked about the elements panel and the console panel, right? Touched on both of those. Have you talked about any of the other panels yet?
Not really.
Okay, we're gonna learn about a new one today, and that's the network panel. So if you open up your developer tools and you go to network on the side, you're gonna see something that looks kind of like this. And this is a really helpful view when you're trying to troubleshoot network requests that a web page is making. Now let me explain what this is. So this is a list of every web request that is made by this page. So if I clear this list, which I can do by clicking the little slash button in the upper left-hand corner up here, and I reload the page, what I'm going to see is all the requests that are made by the page. Also, I should see them in order. For some reason, there we go. That's better. So what I'm seeing here at the very top is this index.html. And when I load the page, this is sort of the first thing that gets requested, the HTML data. So a request is made to this URL, and a response comes back from this URL, and that response contains this HTML, which looks a lot like this, doesn't it? This pane here allows you to sort of see all the information about that request. See the URL, the method, the status code. and then all the headers and the response and the request, and then the body. So this is something where you can sort of really understand exactly how the browser made that request. And then you see below it, there's a request to fruit here. That's this request. So this first request here is a request that the browser made automatically. And you can see under here, under type, it's called document. And under type here, it's fetch for this other one because fetch made this request. And this is sort of, now you can sort of look at all the details here. So the request URL, status code, request method, all this sort of stuff here, headers, the response, you can sort of see it in a couple different ways. And then down here, this WS thing, this is sort of a behind the scenes feature that sort of allows the web server to sort of live reload stuff. That's not all that important for what we're talking about now, but it is there. But in general, this is sort of, let's say you're making a request with fetch and for some reason it's not working and you can't figure out why. One of the first things I would suggest doing is going into the network panel, reloading your page and finding the row that sort of corresponds to your request and making sure that all the data in this matches what you think it should match. Because if this lines up and does what you think it should do, then you should be making the right request. This is like a way you can check to make sure the browser's understanding what you're telling it to do. Does that make sense? Cool. One other thing I'm going to mention. So you remember how I talked about earlier in this class how curl is often used as a way for software developers to communicate with network requests between each other. One of the most helpful features in this panel is if you right-click on one of these rows and you go copy, you can actually copy any of these requests as curls. So if I go copy as curl here, and I go to like a terminal, and I Command V to paste, that's going to paste a curl in here. And you'll notice -H. Some of this stuff probably looks familiar. So why is this cool? Well, this means if you have a request that you're making in fetch, you can very easily copy it as a curl and bring it into Postman. Or you can send it to your coworker who's having some trouble and needs to troubleshoot the thing. This is a very common thing that you'll do if you do front-end development and work on a team that has back-end developers. You'll have a request that won't work, and you want to send it to the back-end developer. So what you do is you copy it as a curl from the dev tools, and you send it to them in Slack or email or whatever. And now they have a command they can run to reproduce your request without your whole front-end application, your web app to have to run. Anyway, so that's the network pane. I just want to sort of make you all aware of it. It's a really helpful debugging tool. But we are going to start going through the exercises here. And I don't know if we're going to get through all of them in time. Oh, yeah. This is sort of, I have this sort of slide. It sort of has 3 examples of one request. It's sort of done with 3 different ways. So if you sort of are a fan of the whole Rosetta Stone sort of idea, where you can sort of see 3 things all with the same, all do the same thing, this is maybe a good slide to look at here. I'm just going to skip by it for now, but it's there for your reference if you want. So for the exercises, we've got the same requests we keep doing, but this time I want you to make them with fetch. And what I would recommend is this document that I had you copy over, update this fetch, sort of make the request. So sort of go in there, update the URL, add the method, the header, all that stuff in here, and then sort of go over here and reload it and make sure the proper stuff shows up in the JavaScript console. So for this first one, we're just going to do the same endpoint we keep doing here to begin with. I guess actually we kind of already did this one, didn't we? Yeah, we kind of did. Well, never mind. Okay, I guess we're going to the next one then. I prepared a little too well here, I guess. Okay, this one, text processing frequencies. So give it a shot. Let's see how it goes. And we'll work through it here if you have some trouble. Okay, how's it going? Figured it out? Still need some help? Need some time? Seeing some thumbs up, so that's good.
You could use some help.
Sure.
Thanks. Thought I got it, but I do.
Oh, do you still need help or you got it?
Oh, no, yeah, I still need help.
Okay,
Sorry.
okay, cool, cool. Let's share a screen. Let's take a look. Okay.
Sure.
So let's take a look at line 8 to 12, sort of that area around that fetch function you're calling. So you have the fetch function, you've got the open parenthesis on line 8 and the close on line 12. So you're sort of passing two parameters into that fetch function. The first one is the URL, which it looks like you've correctly entered, which is good. The second one is sort of the options you pass in to make the request. And it looks like as the options, you've sort of given one of them method mapping to post, which looks right. And then below that, so after that, you have a comma and then an open curly brace, and then body, and then sort of a closed curly brace. I'm curious, what are those open curly braces and closed curly braces look kind of suspicious to me because they're not really like, they're sort of not doing anything necessarily. Like you sort of just kind of seems like you sort of stuck them there. I'm curious, like what, oh yeah, go ahead.
Sorry, then maybe I just didn't see it right. I thought I saw them when I had to post or put something in the body.
Ah, that's for the headers. So if you want to specify headers, the headers are a bunch of key value parameters. So you sort of need to like tell it which parameters to use. Yeah, there we go. Well, looks like you figured it out.
Okay.
Generally, you'd also indent line 12 underneath methods. You sort of have them in line with each other. But that's kind of nitpicking.
Okay. Thank you.
Sure. Cool. Anybody else? Okay. I guess we'll keep moving forward then. Let's do the lockbox one. So this one, we've got a get request with a header, but no body. Okay. How's it going? Success? Not so much?
So for head, sorry, so for headers, you put, when you write out the code, for header, you put headers with quotation, then authorization, then. Can I just show you what I have? Maybe
Sure.
that would make a little bit more sense.
Yeah.
So can you see this?
Yep.
So right here, you would put headers, even though it's one header.
Yep. Yeah.
Okay.
So you can think of headers as the key, and the value is the object that contains the a bunch of headers that are paired with each other.
Okay.
So the reason why it's done like this is if you just imagine you put all the headers in the root, like imagine you wanted to make a header called method. Like you
Mhm.
wouldn't be able to do that because you've already got a key method in that root level. So by making a second level like that, it sort of allows you to make a discriminated set of headers that are like specific to headers and aren't just like couldn't conflict with like the names of the other things.
Okay. Yeah, no, that makes sense. I just didn't know if it was headers, if it was a singular, and if it was just one singular header on there, but I understand. Makes
Yep.
sense.
Cool. Okay, well, I saw some thumbs up, which is good. And if anybody has any questions, let me know. Otherwise, guess we're just gonna keep moving forward. I mean, I'm cautiously optimistic, but like, please let me know if you're having trouble. I want to help you out.
So far, so good, but I'll definitely want more review.
Yeah, so I think for that reason, we're gonna do one more exercise. So we've got this one and this one, or sorry, this one and this one, which are sort of similar. I'm gonna leave these two for you to do on your own if you want. But we're gonna do the dump headers one, because that one has two headers and a different method. This one's got some more interesting stuff going on here. So give this one a shot. And then I think after that, we'll be about done here for today.
What's supposed to be the output on the console for this?
let's I think you should see hello world, this is the header and this is the value, but let's go through and check, make sure. I just didn't go through the other ones, which maybe in hindsight I should have. So we've got this here. I'm gonna add in our dump headers path. So dump headers. Our method here is put. Update that. Headers. I'm gonna do that inner object. Header name is hello. Header value is world. And this is a header. This is a header. And this is the value. Something kind of like that. Okay, so I'm going to go save that and come over here. I get this, headers, and I get a bunch of headers. So one thing I want to call out here is there's a lot of headers in this list, and many more than sort of we included. So there's the ones we included, like there's hello and world, and this is a header and this is the value. So ours are there, but see, there's a lot of other headers it decided to include. And it's a bit of foreshadowing for tomorrow. We're going to learn about what all these headers are for and what they do, or what most of these are for and what they do. Not all of them. But you should see something kind of like this.
Is this like when we were using Postman and there were like some of those headers were like pre-checked?
Exactly.
Before?
Yeah. So we've talked about custom headers, but generally there's a lot of headers that just ain't included along with many requests, with most requests. So we're going to talk tomorrow about what those headers do and what they why they're important and sort of how to understand what they're about. So when you see them, you'll sort of know what to do there. We're not going to talk about all these, but probably like a third to half of them, the most important ones. Cool. Any questions? Okay, so I think that's about it then. I'm hoping, and it sounds like that it might be the case, that people are coming out of this class with a lot more confidence around promises than they came out of Wednesday with, which if they did, then that's, I feel like we've accomplished something. Cool. Okay, sweet. So if you want some more practice on your own, feel free to do these other two exercises here on slide 153 and 154, but up to you, they aren't required, just if you want some practice. And tomorrow we're going to talk about popular headers and cores. So yeah, I forgot we're talking about cores tomorrow. Nice, cool. Okay. Sweet.
I have one thing that I didn't have work is, and this is the value supposed to be in quotes as a string or not? Because it's telling me unexpected string on that line.
Needs to be in quotes.
And same with this is a header.
Yep, your key doesn't have to be, but should be. Well, I guess in this case you got dashes in it, so yeah, it would have to be. But yeah, put your keys in quotes.
Okay. It doesn't like
it.
Dump headers. Good.
Would it be helpful to share your screen?
Yeah, I was just gonna ask.
Cool.
You gotta be careful. Sometimes Prettier will try to convert stuff too, like if it thinks it should be a string or vice versa.
So in general, when you write key value pairs and objects, you have to do key, colon, value, and then a comma after the pair to sort of tell it to move on to the next one. Yep, I bet if you save that, it'll work fine for you. Yep, it looks like it did.
Okay. That's what I missed.
I'll say in general, in each of these, you've been very close. It's just like one small little detail. So, but you're generally seems like you're getting it.
Okay, well. Awesome.
Cool.
Thank you.
Sweet. Okay, well, if there's nothing else, see you folks tomorrow. Have a good evening.
Have a good night.
Thanks, you too.
Bye.
Bye, guys. Thank you.